Hello everyone. This video is on the Knewton Alta assignment for section 3.2 called Graph Lines Using Slope-Intercept Form. Alright, so in this video I'm going to be taking you through a preview version of the Knewton Alta assignment for section 3.2. So here's what I'm looking at, what the assignment will look like. On these pages, in the upper right corner, you should see the mastery bar, which tells you how far along you've gotten. You have a current objective. Underneath this, if you click on the down arrow, you can see all the objectives for this assignment. It looks like there are 3 of them. And under the current objective, you will see a question related to that objective. And at the bottom of every question, you should have a feedback button where you can send feedback to Knewton if you wish. You will not have an instructor cheat button, right? This is for instructors only. And you will have, though, the more instruction button if you are struggling with a topic or a particular objective, a particular question. I would recommend clicking on this and going to further instruction. You'll be given further reading or videos to watch, and then questions related to that instruction. And completing those questions will get you through the assignment just like completing the main questions will. Okay, so the first objective I'm looking at is graph a line given a point and the slope. So for this one here, we're asked to graph the line passing through the point -6, -2, and whose slope, which is usually represented by a lowercase m, is -2/3. Okay. So the point on the line is the point with x coordinate -6, y coordinate -2, and the slope, right, again lowercase m, is -2/3. Now remember what slope is, right? Slope you can think of as rise divided by run. This is vertical change divided by horizontal change, sometimes represented as delta y divided by delta x, where this delta symbol just simply means change in. Okay. So when I'm on a graph, and I'll make a rough XY coordinate plane here, first I'll plot the point -6, -2. So -6 on the x-axis, so that's left 6 from the origin, and then -2 on the y-axis, right? So that's this point here, -6, -2. So that's the point they gave me. So I plot that point, and then having a slope of -2/3, you can think of the numerator as -2, the change in y, the rise, and the denominator as +3, or the change in x, or the run. So a rise of -2 simply means from any point on the line, we can go down 2 units. So if I go, down 2 units, let's put a little arrow here, right? I'll be going from a y coordinate of -2 down to a y coordinate of -4, right? That's down 2 units. And then a run, a change in x of +3, means, go to the right 3. Positive changes increase values. negative changes decrease values. So positive 3 means, go to the right 3. So currently I'm at a point with an x value of negative 6. If I go to the right 3, I'll be at an x coordinate of negative 3. So from this point that they gave me down to right 3, I land here. Right, at this point, the coordinates of this point would be negative 3 for the x, negative 4 for the y. And you can keep doing this. Just keep going from any point on the line down to right 3, down to right 3, down to right 3, and so on, and plotting more and more points. But you'll notice that every single one of these points will be on, a straight line. So 2 of them should be enough. So I've got 2 points here. I'll pull out a little ruler. You don't need a ruler, but and then the line should be all these points here. Right? All the points falling on that line with those 2 points, negative 6, negative 2, and negative 3, negative 4. Right. So back on the assignment, we're just asked to move these 2 blue points around with our cursor. All right. So one of those points was at negative 6, negative 2, and you can even click on the point and it'll show you the coordinates. Right, that was one of the points. And then on the graph I made by hand, right, went down to right 3. Right, so from this point, right, down to right 3. And there's the point negative 3, negative 4, right? That was also on my graph, and there's a line going through the point negative 6, negative 2 with a slope of negative 2/3. Right? And then once I've entered my answer, I hit submit. Right? And it tells you, great job if you did it right. It gives you a green bar. If you got it incorrect, it'll give you a red bar and give you some sort of message of encouragement. Right? Keep trying. We learned from mistakes or whatever. And then beneath every answer, whether you get it right or wrong, you'll see an answer explanation. So please look over these, right, just to make sure hopefully you can read through these answer explanations and understand why you got something correct or incorrect, and hopefully learn from your mistakes. All right, so moving on. Still the same objective, graph a line given a point and the slope. Right, so this is graph the line passing through the point negative 6, negative 3, whose slope is 2, positive 2. So I'll just do this one here on the screen. So negative 6, negative 3. I move one of these points to negative 6, negative 3, right? And see, there's that point there. Now they say the slope is positive 2. So the numerator is 2, and the denominator would be 1. Right? If there is no denominator, there's technically a denominator of 1. So rise positive 2, run positive 1. So I'll move this other point to the point negative 6, negative 3 as well. And then from here, we go rise positive 2, so up 2 units, and then run positive 1, so to the right 1 unit. So up 2 units, right 1 unit, and that lands me at the point negative 5, negative 1. And they have the line drawn through those 2 points here. So here's the line going through the point negative 6, negative 3 that has a slope of positive 2. Again, you can do these by hand if you wish, and then come back to the assignment. But I'll just do that first one by hand and do the rest of these on screen here in the assignment. Here's another one, same objective. So graph the line that passes through the point 6, 1. Whose slope is positive 3, right? So again, I'll move one of these points to the point 6, 1. There's the point 6 to the right, 1 up, from the origin. I'll move the other point to the same place, and then from there, the slope is positive 3. So up 3 units, right 1 unit, right? Remember the denominator would be positive 1. So rise positive 3, run positive 1. That takes me to the point 7, 4. And there we have it, the line containing the point 6, 1 that has a slope of positive 3. All right, and there should be one more of these from this particular objective, and then we'll move on to other objectives. So you see my completion bar is 3/4 full here, so I'm doing this one more time. Graph the line passing through the point 3, 4. All right, so I'll move one of these points to the point 3, 4. So right there, right, there's the point 3, 4. I'll move the other point there as well. And I want the slope of this line to be negative 1. So the numerator is negative 1. The denominator is positive 1. Again, if there's no denominator, you can always say the denominator is positive 1. So the rise is negative 1. Right? So from this point 3, 4, I go down 1. Right? The rise is negative 1. And then the run, right, the denominator, the change in x, is positive 1. So I go right 1 again. So, and then we land at the point 4, 3. So from 3, 4, I went, down 1, right 1. And then you can keep doing this, down 1, right 1, down 1, right 1, and you see you still land on points on the line. So here we have it, the line passing through the point 3, 4, that has a slope of negative 1. Great. All right, so that objective is complete. And we move on. All right, so the next question is on the objective, identify the slope and y-intercept from an equation of a line and relate a graph to the equation. All right, so here we're asked to identify the slope and y-intercept of the, here's an equation for a line with x and y, 8x to the first plus 6y to the first equals 18, right? This is actually in that standard form for the equation of a line, which I'll talk about here. Right? So they're giving us an equation in what's called, standard form. Right, that's where you have some number times the variable x, so ax, plus some number, which I'm calling capital B here, times y equal to some number, which I'll call c. Ax plus by equals c. So that's the equation they gave us, right? It's 8x plus 6y equals 18. Now there are other forms. As well. The one that is in the title of this section, right, section 3.2, in the title they mention slope-intercept form. For a linear equation. All right, and the slope-intercept form looks like this. Y equals m times x plus b, where the coefficient of x, the number attached to x, is the lowercase m. That's the slope of the line. And then the y-intercept remember for the y-intercept, right, the y-intercept of a graph is a point that's on the y-axis. And if you're on the y-axis, the x-coordinate is 0. Right? So the y-intercept always has an x-coordinate of 0, and you can see from the form of the equation, if x were 0, that would make this mx term disappear, and you'd have the y-coordinate equal to b. Right? So 0, comma b would be the y-intercept. So the name of this is slope-intercept form because when you see an equation in this form, you can easily identify the slope of the line and the intercept, the y-intercept. Now to get an equation in this form, you simply solve for y. So if I wanted to take an equation, say in standard form, and put it into slope-intercept form, I just need to solve for y. Right, because you see here it's y alone equals, and then over here there are no parentheses or anything, it's just a simplified expression. So I take 8x plus 6y equals 18. Alright, and then we're going to solve for y, so I want to get all the terms that don't have y to the other side, right? So first I would subtract 8x from both sides. So that gives me now 6y equals, and then over here, I typically like putting the variable terms first. We have negative 8x and then positive 18, right, plus 18. And then finally, to get it in slope-intercept form, I want 1y, not 6y. So we need to just divide everything by 6, right? Divide both sides, divide every single term by 6, and simplify as we go. So 6y divided by 6 is y equals negative 8x divided by 6. Well, negative 8 divided by 6 is negative 4/3 when you reduce, right? They have a common factor of 2. So that's negative 4/3 times x plus, and then 18 divided by 6 is 3. Right. And here we go, right? This is an example of an equation for a line in this slope-intercept form. Y equals mx plus b. So the slope, right, the lowercase m here, the slope of this line, is the coefficient of x. It would be negative 4/3. Negative 4/3 would be the slope of this line. And the y-intercept, again, the y-intercept is the point of the graph that's on the y-axis. So it has an x-coordinate of 0, always, right, for the y-intercept. And you can see very clearly, if the x-coordinate were 0, if x were 0, this would be gone, this term, and you'd have y equals positive 3. Right, so the point 0, 3 would be on the line. Right? So there's the slope and y-intercept of this line. And you can make a graph, just like we made graphs earlier. Plot the point 0, 3, and then use the slope, go down 4, right 3, and you'll get another point, and then you can make a drawing. But I am not drawing this line. All we were asked for was the slope. All right, so I enter negative 4/3. And the y-intercept, right, x-coordinate 0 always for y-intercepts, y-coordinate positive 3, and submit. Great. All right. So next question. So it's from, looks like the same objective. So once again, we're given an equation that's not in slope-intercept form. I should be able to, put it in slope-intercept form and then identify the slope of the line and the y-intercept of the line easily from there. All right, so I'll write this out on a separate page. So the equation we're given here is negative 2x plus 5y equals negative 30. And once again, if I want to put it in that y equals mx plus b form, slope-intercept form, I would like to solve for y. So let's get rid of the 2x, well, the negative 2x, right? So I'm going to add 2x to both sides. Right? So that gives me positive 5y on the left equals, and then over here, positive 2x minus 30. Right? And then I want y by itself, right? So the times 5 here, let's get rid of the 5 by dividing everything by 5, right? Both sides, divide by 5, divide every term by 5. So on the left we have y equals 2x, divided by 5. 2 divided by 5 is just simply 2/5. So this is 2/5 times x, right? That first term. And then the next term, right? Negative 30 divided by 5 is negative 6. So here's the equation in slope-intercept form. Right. And I can easily now identify the slope, right? That lowercase m. It's just the coefficient of the x once you've solved for y. It's 2/5, positive 2/5. And the y-intercept, I'll just put y-int, has an x-coordinate of 0, right? And if the x were 0, you can very clearly see that y would have to be negative 6. And there we have it, right? These are the pieces of information they're asking us for. The slope of the line and the y-intercept. And once again, you can graph this if you wish. Plot the point, right, 0, negative 6, and then use the slope, from that point, go up to right 5, and you'll land at another point, and then you can graph the line, but we're not asked to do that here. Just what's the slope? Positive 2/5, and the y-intercept, x-coordinate 0, y-coordinate negative 6. Right, and submit. Wonderful. Okay, moving on. Alright, now we're in the other objective that's left. We'll bounce back between these two, I think. It says graph a line given its equation using its slope and y-intercept. So this time, I'm going to do what I was doing in the previous two examples. I'm going to solve for y. I'm going to put the equation in slope-intercept form, and then we also now must graph it. Alright, so I'll move one point to where the y-intercept is, and then from that point use the slope to get to another point, the rise and the run, and then we'll have a nice graph of the line. Alright, so the first one I'll do by hand. And so the first the equation we're given here, 5x minus 2y equals 0. Alright, now I'll just, if I were to solve for y here, I'm going to kind of skip ahead, I would subtract 5x, giving me negative 5x on the right side, and then dividing by negative 2. Negative 5 divided by negative 2 would be positive 5/2 times x, right? And then plus 0. I mean, the constant on that other side is still 0. And 0 divided by any non-zero number is still 0. So here's the same equation in slope-intercept form, right? And the slope of this line, once you solve for y like this, is the coefficient of x, right? Positive 5/2. And the y-intercept, if x were 0, y would also have to be 0. Alright, so the y-intercept is the origin. And then when we're making a graph, I plot the y-intercept. Right, so here is the y-intercept 0, 0. That's a solution of the equation. That's on the graph. And then the slope, the numerator is positive 5, the denominator is positive 2. So I go up 5 from the y-intercept, and then right 2 from that. And then we get another point. So if I go from here up 5, right 2, here's another solution of the equation, 2 comma 5, right? And you can check it. If x were 2 and y were 5, you'd have 10 minus 10 equals 0, and that is true. But those aren't the only two solutions, right? I mean, all the other infinitely many solutions are on the same line as these 2 points here. So there you have it, right? All these points I just plotted are also representing solutions of the equation. But back in the assignment, right, I know they already have one of the points at the origin here, 0, 0. That's fantastic. I just need to move the other point to 2, 5. Right, that was up 5, right 2. And there you go. And this is the line that I drew by hand on paper. Wonderful. All right. Now we have another question from this same objective. All right, so I'm going to do the same thing again. I will put this into slope-intercept form. Plot then on the graph here, I'll move one of the points to the y-intercept, and then move the other point using the slope of the line, going from the y-intercept to another point. All right, so we have 5x plus 2y equals 12. Right. Now I'm going to describe the steps I'm doing. I'll just tell you what I'm going to get in the end. So first, I would subtract 5x. That would give me negative 5x plus 12 on the right side. And then divide everything by 2. You'd have negative 5 divided by 2, negative 5 halves times x, plus, and then 12 divided by 2 would be plus 6. So there's the equation in slope-intercept form. All right, so the slope is negative 5 halves, negative 5 over 2, and the y-intercept is the point 0, 6. Right. So back on the graph, I'm going to plot the point 0, 6, and then go down 5, right 2. Right? The numerator is negative 5, the denominator is positive 2. So here's the point, here's the y-intercept, right? 0, 6. And then if I go down 5, right 2, I'll be at the point 2, 2, 1. Right? The y-coordinate got decreased by 5, and the x-coordinate got increased by 2. Right? Down 5, right 2. And there you go. And you can double check, when that this is a solution. When x is 2 and y is 1, you'd have 10 plus 2 equals 12. That would make the equation a true statement. So it is a solution. And then all the other solutions are on the same line with these two. Right? Wonderful. All right, moving on. So back to the objective where you're just asked to find the slope and y-intercept. All right, now this is great because see how it's already solved for y. Y equals, and then x divided by 2 minus 7. Well, x divided by 2 is the same as x times a half, right? The coefficient of x here is 1 over 2. So the slope, it's already in slope-intercept form. The slope of this line then is 1 over 2, 1/2. And the y-intercept, x-coordinate of 0. And very clearly you can see if x were 0, y would have to be -7. So that was a pretty quick one, right? It's already in slope-intercept form. And then one more of these where, once again, the equation we're given is already in slope-intercept form. Y equals mx plus b. The coefficient of x, right, which is the slope, is just 1, right? That's 1x. So the slope of this line is +1. And the y-intercept, right, if x were 0, clearly y would have to be 7, right? The point 0, 7 would be the y-intercept. Great. All right, so I got just that last objective to finish up, where we're putting an equation in slope-intercept form and then graphing. Well, just like the previous two, we're very fortunate again. The equation we're given is in slope-intercept form. It's y equals -2/3 times x plus 0. Right? If there's no constant afterwards, it's plus 0. So the slope is -2 over 3, and the y-intercept is 0, 0. So the origin is the y-intercept, so I've already got that. And then the slope is -2 over 3, down to right 3. So from the origin, I go down to right 3. That's the point 3, -2. And here are all the solutions, the graph of this equation. Pretty simple if it's already in slope-intercept form, in my opinion. All right, and then I should have just one more of these left. Typically, if you're doing things correctly, you'll only have to do 4 questions to complete an objective. All right, now this one, this is not in slope-intercept form, so one last time I'm going to go to the paper and put it in slope-intercept form, and then we'll graph. So the equation we're given this time is 6x minus 2y equals -2. And like I did in the previous examples, I'm just going to tell you the steps and that I do and write the equation in slope-intercept form. So I would subtract 6x to give me -6x minus 2 on the right side. And then we would divide by -2. Right, so -6 divided by -2, that'd be +3x. And then -2 divided by -2 would be +1. Right, so the equation in slope-intercept form is this: y equals 3x plus 1. So the slope is +3, or 3 over 1. And the y-intercept is the point 0, 1. Right? If x were 0, y would have to be 1. So I'll plot the point 0, 1, and then from there move up 3, right 1, right? Using the slope to find another solution. So 0, 1 is the y-intercept. Right, there it is. And then if I go up 3, right 1, I'm here. I'm at the point 1, 4. Right, the y value got increased by 3 and the x value got increased by 1. Slope of 3, up 3, right 1. And there you go, and the rest of those points should be solutions on that line. Great. And that should be all for this practice version of this assignment. Just double check here. Yes. Okay. So please understand that this was a preview version of the assignment, right? So that means the questions I saw in this video, they might not be the exact same questions you see when you work on the assignment yourself. But my hope is that, these questions should be similar enough to the questions that you see so that watching me do them here will help you out, hopefully, in some way when you work on the assignment yourself. Right? And thank you very much for watching.